Let's take it easy. We can introduce ourselves. They won't care who we are. So who are you?
So I'm Bill Wagner. If you read docs on docs.microsoft.com under C#, that's what I'm responsible for. A lot of the newer ones, since I've only been with the company about 2.5 years, I've been writing. And I try to explain the amazing things he comes up with. So who are you?
I'm Mads Torgersen, and I'm a program manager on the .NET team, and I'm the lead designer for C#. So I come up with the crazy things, and then he makes them sound like they were planned and thought out. So it's a good partnership, and we couldn't resist the opportunity to grab a Shakespearean title here. So honestly, what happened? Again, let's start a little slow. People are still coming in. So what happened was. These new features are about to come out in C#, and a lot of people are interested in them. Lots of Microsoft people apparently said yes to come here at the same time. And so we all submitted the same talks with the same titles and the same abstracts. And then when we realized that we were about to do the same things, we were like, oh, 2 talks about nullable reference types. Right. Why don't we join up and then make it like a 2-hour tour de force essentially about nothing?
We figured Seinfeld succeeded, so 2 hours about nothing. Should we do it? All right.
Yeah. So this is Much Ado About Nothing, Act 1, in which I'm the hero, meaning that I will do most of the talking, and I got the keys. And then I'll try to be nice to Bill, because in the second act, which is after the break, he will have the keys and he will have the power, and whatever I do to him, he will do to me 100-fold, which is, all Shakespearean and good.
Talk is tomorrow, so we will both be there. No.
Yes, so we should be nice to John as well. John Skeet is here on the front row. He also submitted the same talks, so sorry about that. We will start out by sort of exploring the general, the history and nature of null references, and also what we've tried to do about it, or what we're trying to do about it in C#. So the sort of language design aspect of what we're calling nullable reference types.
So the history of nothing.
The history of nothing. Yes, we can make this joke a lot of times. It doesn't get any funnier.
No.
It's essentially vacuous. So so that's sort of like the language designy stuff, maybe the computer sciencey stuff a little bit. And then there's like, okay, how do I actually use this? What does it mean for me in source code? And that may be a little more C# specific. There's going to be more code in Bill's section, but also much more practical. We're about C#, but I think that a lot of what we're doing with this feature is relevant to pretty much any object-oriented language on the planet. So, and maybe more. So, even if you're not a C# developer, how many people in here are C# developers? Okay, let's just get that out of the way. Okay, how many are not? All right, okay. Well, there we go. So I think people have stopped filing in now. So let's dive into the substance here. So we all know that truth is found in nursery rhymes, in particular the British ones. I love the British ones because they're all about gently introducing unsuspecting kids to the violence and death that surrounds us in society. Like they're pretty gruesome, and so this is no exception here. And this particular one is about nulls, right? There are all these sheeps that are missing, the null sheep, as it were. They're just these empty shapes left. And as it goes, little Bo Beep has lost her sheep and doesn't know where to find them. Leave them alone, and they'll explode, throwing exceptions behind them. Right? So that pretty much expresses what we all know and feel. And have for the last many centuries of object-oriented programming. So there's a villain in this story. You see this villainous, evil grin here. This is Sir Tony Hoare. He's one of the grand old fathers of computer science. He's still around. He joined Microsoft Research in Cambridge right around the time where I was interning there 2 decades ago. And he's retired now, but he still comes in on Thursdays because he just, can't help himself.
Now, I heard he's helping Don Syme introduce nulls to F#.
I think, yeah, that's probably true. So he once famously claimed that that null references were his billion-dollar mistake. Like he gave a very quoted talk where he essentially sort of tongue-in-cheek took responsibility for all the billions of dollars that have been wasted on null reference exceptions over the course of history, because he actually invented null references. And it's pretty amazing that something like that was ever invented, right? But actually they were. Like, he was there along with Niklaus Wirth, trying to come up with a proposed successor to Algol 60. They're like, there've been these advances in computer science. Let's try to propose a new version of this very popular imperative language called Algol. And they called it, it's been referenced Algol W. So they came up with really great things like reference types, okay? So you can point to other things, and that can all be typed and expressed in a type system. And at the end of the day, Algol W was rejected by the Algol committee. They had much more important things on their mind, and they went and took Algol 68 in a completely different direction, and it totally tanked. Right? Instead, Niklaus, Tony's partner in crime, went and came up with this thing called Pascal. Okay, taking these ideas from Algol W and turning them into a different programming language, which of course became the, essentially the lingua franca of high-level imperative programming for decades after that. So even though Algol W never really became anything in and of itself, it had a massive impact on the history of programming language, massive. And the other thing that it influenced with the reference types was the first object-oriented programming language. Here's sort of a quick genealogy of programming languages. Algol W here never really was released. Nobody wrote code in it ever, except for Tony and Niklaus themselves. But it has had this massive influence, including on Simula 67, which was the first object-oriented programming language. And then, of course, all the languages that followed. And essentially, not only did reference types make it across to object-oriented programming, our central concept in object-oriented programming, when you think about it, but the null references sort of came along this disease vector as well, and they infected all of object-oriented programming through these arrows here. When you think about it, objects really object-oriented programming can't exist without this notion of reference types. So Simula introduced the notion of inheritance, and you have these different classes that are abstracted over by a shared base class or superclass, right? And that can only really work if you're sort of indirected through a reference. They have different sizes and shapes, right? There has to be this indirection in order for that to even work. And the references themselves become object identities, which is a central concept in object-oriented programming. So Algol W really opened up that whole thing and made Simula 67 click, together with these notions of inheritance and so on that they added. Just because NDC is rooted in Norway, I want to put the two Norwegian inventors of object-oriented programming up here on a slide as well. Very cool people. From there, I'm really going to, that's sort of a gentle introduction to the topic, but I'm really just going to flip into Visual Studio now and do the rest of the talk in code.
Code's more fun. Code's good.
Yeah, right?
Yeah.
And I don't think people, I think people will appreciate having live explosions instead of ones on slides. So let's go and make some live explosions. So one of the things, so I want to start by talking about, sort of intuiting what might have happened in Sir Tony's head, One of the things that you can do with reference types is that it's really good for expressing recursive types, right? So let's say he's implementing linked lists in Algol W back in 1965, and he's there, he came up with this recursive, I'm writing it as a class here in C#, but he came up with this recursive type that's sort of a linked list. Okay, and so he's like, okay, what does the linked list have? It has some content in the node, and then it has a link to the next one. And a constructor. Okay, that's good. So let's create ourselves a link here. Okay, we can, and I just made one of strings here to make it easy. I don't think they had generic types back then. So, we can say new link of hello, and then we need another link. Okay, so I can create another link and say new link of world, and then I need another link. And so at some point, this has got to stop. I can't keep creating new links and passing to it. So at some point, I have to pass it something other than a new link. Okay, and it's like 3 a.m. now, and he's tired, and he's like, all right then. Okay, let's put this thing in here. Okay, let's add that to the language so that I can stop creating new objects and end my statement here. And so null is introduced. It's a thing that you use when you have no more things. And,
it looks so innocent.
It looks innocent, right? And it's kind of almost necessary. It's pretty well motivated. All right. And now the next morning, Niklaus comes in, and Tony's fast asleep. He didn't even show up until after lunch that day. But Niklaus is like, hey, he put in recursive types. I'm not going to do the German accent. And he's like, hey, let me write this out to screen. Static void. I'm just totally pretending this is algol W. I'm just doing it in C#. Okay. Static void print. Let's take a link, and let's print it out. How hard can that be? So let's see, what does it have? I can right line the link's content, so there's a value in there. Great, I printed that first one out, and then we can it's a recursive data structure. We can just recursively print out the rest. Link to next, done, Great, wonderful. And we compile and we run, and
you're not actually calling it.
I'm not calling you. That's a good observation. Okay, let's actually call it. So print of that thing I just created. Okay, now I think we compile it before I call it. So let's call it again.
There we go.
And boom, we have an exception. The world's first null reference exception has occurred. So that's what I mean by live explosions. So we printed hello, we printed a world, and we ran over the edge, and we died. And of course, this has been with us ever since, because we never really dealt with this. It was like, okay. Back then, we had bigger fish to fry. But we never really recovered from this. And so this is C# today, perfectly legal program, runs over the edge, just like in algol W 54 years ago. And that's not entirely good. So Tony's right. He's kind of tongue-in-cheek when he says, I'm sorry for ever having invented the null reference, because what else would you do? What else would you have done? Right? How else would you have solved the, I made it to the edge kind of problem? But what he means is, we just introduced this thing completely outside of the type system, and we're not even trying to deal with it. We're not even trying to introduce the kind of type safety that we apply to everything else. Okay. Right. So the question of what else could we do has been riddling us ever since. The functional folks, they have it figured out. Okay. So if you go to look at functional programming languages, they've dealt with this pretty neatly. And what they said is, so they have a very reasonable line of thinking about this, which is saying, okay, we shouldn't be talking about just the link type here. There's links, and then there's not links. There's two different kinds of things. There's I have one and I don't have one. And those are two different kinds of values, so they're two different types, and we can have a union type between them that says this particular field or parameter or whatever is either that or the other. Okay, so they have this notion of union types, and based on union types, we can express, as a special case, things that are either there or not. We don't have union types in C#, but you can model it pretty well using inheritance, right? So actually, starting with similar, they had no excuse. They could have done this. But we can say there's an option of t. I made it generic here. An option of t, which has a derived class is none or some, which is either there was nothing, so there's this empty class here for when there's nothing, and there's another subclass for when there's something. And they're all options of t's, so I can abstract over whether it's nothing or something. And now the something has a value inside, and it can be constructed, and it can be deconstructed, like we do in modern C#. So we could go and solve the problem and sort of put the nulls in the type system. So let's do that quickly here. It gets a little more tedious, but that's mostly because the language it's not completely native to the language. So instead of having just a link next here and relying on the ability of that to be secretly null, we're going to be explicit and say this is actually an option of link. There either is a link or there isn't. If I could hit the keys here, so it's option of link next. Okay? And now, of course, I need to adjust my constructor a little bit. But that's pretty much it for the implementation. But now we see warnings show up in two places. First of all, my constructor changed. I need to do some more constructing here in order to get those option types in. But this warning down here is, or this error down here is what I want to get to in a minute. But let's make it happy by creating instead of passing a link to the constructor, I have to create a sum link that has the link inside. And instead of, let's see, I can keep my parens straight here. And instead of passing a link.
Oh, I think the type needs to be capital L.
Oh, yeah.
It's just pair programming. It's all good.
That's great. And now that goes away.
Yep.
I can still pass a null here, but I really shouldn't. I should be passing a new none of link and put the safe null in there. Okay? So I have a none at the bottom, and then I have sums clapped around it. So now we made a type-safe version of the linked list. And what we have down here shows that it's type-safe. We have the link.next here is no longer allowed because, well, first of all, it's not allowed because I can't print an option of link. I can only print a link, right? The print method isn't recursively calling itself yet. Well, how do I get to the next link so I can print it? I have to fish it out of the option, but I can only do that if the option is a sum and not a none. So I have to do it conditionally, okay? So it's forcing me to say if link.next is a sum of link, then deconstruct it and get the next link out, okay? And now we can, in this if statement here, so I get a fresh variable with the link, but only if it was there, only if the thing was a sum. And then inside of the if statement, I have that next variable that actually refers to a link and that I can recursively print out. And so now I have the safe printing that I think we should even try to compile and run and see that it does the right thing now. Okay. So it forces me to check for null. The type system forces me to check for null. Right?
I like that.
Okay. So that's the kind of thing that we want. Have the type system help us realize that we have a null problem. And now, this particular way of going about it, it's fine. We can just have a language without native nulls in it, and we can just build our own nulls with using discriminated unions. It does have some limitations, right? This is one way of using nulls where you really want a null. You really want, in the finished data structure, you want there to be an end. You want there to be there's no more here. But sometimes that's not what nulls are for. Sometimes you sort of have, as you're building up your object graph, you have temporary nulls, right? This is all from functional programming, which you construct values from other values, always, and in principle, you're never mutating them, right? So you can never actually build a cyclic data structure. Because you always have to have the thing that the next thing is constructed from. So if you want to build a cyclic data structure, well, I can't create this object before I created the one that it points to all the way around, like in the whole cycle. Yes, somebody has to be first. And you know, okay, so if we have a mutable programming language, how do you create a cyclic data structure? Well, you have to create one of the objects first. And then you can create all the other ones that point to it. But at some point, at some point did you create the one that the first object is pointing to. And so in the meantime, what was in there before it pointed to the thing it should eventually point to? So even if you have a finished data structure that has no nulls in it, there's this whole initialization problem of, well, what was it until you were able to assign it the reference? And sort of more in general, most of our more mutation-oriented programming languages, they have more dynamic ways of creating data. Like in C# and Java, you can create arrays, create an array of string.
Yes. And I don't want to like pay for all those constructor calls.
Right.
That would take time.
Yeah.
And I don't know what goes there yet.
So it's fine to so we kind of need this idea of default values. Create an array. You even computed its size at runtime. You're creating an array of string. Well, it'll just be full of nulls because null is the only sensible default value of string. Even if strings were not supposed to be null, like what else would you use as a default value? And the notion of default value, of sort of a zero value, is deeply entrenched in most normal languages, and for a reason, right? It's really hard to create a programming language that's statically safe and does not have a notion of the default value of a given type. So in practice, this runs out of steam in a more mutation-oriented, more object-oriented programming language, this approach. But it has some really, really good properties that we want to latch onto if we're trying to solve this problem for an object-oriented programming language. The key property that I think is the most important one here is that it's explicit about intent. There's link and there's option of link, okay? And there are two different types. One can be null over here and the other one can't, okay? So you're explicit in the type system about your intent. And then the second thing is that there's enforcement of this intent. I cannot possibly, well, I would have to contort myself badly in order to circumvent the type system and get at something that isn't there. It's really hard for me to accidentally get a null reference exception here. Right? Essentially, I have to cast and do unsafe things. So
yeah, the way I've said that when we were explaining these concepts is our type system protects against Murphy, not Machiavelli.
Yes. Yes, so if you really want, yes, you can get into trouble, but you kind of have to ask for trouble more. And so the ideal here is, you know, enhance the type system to allow expressing whether null is intended or not in a given place where you use a type, and as much as possible, enhance the type system to enforce that. Knowing that we can't get all the way there because of these initialization problems, you know, because of default values and stuff, we can't get all the way there to making it 100% safe. And there are other reasons why we can't get all the way to make it 100% safe. One of the reasons being that it's one thing to create a new programming language today and deal with nulls in it from scratch. But we're actually creating an old programming language today, right? We have C# already lying around, had it for 20 years, and now we want to go and fix the type system. And so that limits us so much more in terms of how we can approach this. But we're going to try.
That's good. And this is one of the things I'm really interested in, especially when we get later, when I want to try to migrate some code I have to use this and see, you know, how much benefit do I get and how much does it hurt?
Yeah.
I'm worried about the pain.
Yes. I don't like pain either.
Okay.
So I don't really know why I have this job, but I guess. Yeah, I guess that's Murphy. But I think now is a good time to actually start circling in on, okay, so what did we do in C#? So the first thing is this expression of intent. So I think we have a couple of options, given that we're adding this to an existing language. The first sort of knee-jerk idea is, well, okay, he wants these two expressions of intent. This is definitely not null, and this might be null, but it's protected against unauthorized access. Okay, the reference types we have in C# today are neither of those. Yeah. They're the worst of both worlds, right? They're like, oh, I can shove null in there, and then immediately I can go and click and, you know, dot into it in the next line, literally.
Yeah. So there's some clean stuff there. At least it doesn't make me change any of my code now.
Right.
You don't have that pain if you'd have went that way.
Right. So, but there's definitely a notion of cleanliness that we've operated under for 20 years, which is add new stuff, don't change the old stuff, right? Okay. So we have these two new concepts, neither of which we have in the language today. Oh, we should go and add a new kind of non-nullable reference type and a new kind of nullable reference type to C#. And then people can, in new code, they can party with those and they can be safe all over. And too bad with what's already in there. That sort of becomes the legacy reference type that you should maybe try to avoid, right? So the idea would be something like, this one here, we would call that, and that would be non-nullable, okay? So we annotate it like that. And, well, actually, let's move back to where we don't have the options in there. And it's a little easier to explain this. Sorry for a lot of undo here. The undo buffer, luckily, is large. There we go. I think we're back. OK, so we could say that the string should be non-null, but the link should be null. And we have a new annotation for both. And that's just a new world. That's the new world of C#. OK? And then Bill asks me.
But I've got code I've got to maintain.
That's exactly what he asks me. And I'm like, yes. OK.
I've been writing this for 20 years.
If you want, well, hopefully you tested it.
Oh, yeah.
I can't really help you. If you really want help, what you should do, we should probably have like a Roslyn analyzer or something, or we should have a mode in the compiler that punishes you for all the legacy reference types that you have in there and makes you put either bangs or question marks all over your code. So there will be no like unannotated reference types left in your code.
That sounds like pain.
That sounds like pain, yes.
Yeah.
And once you're done, your code will be swearing at you. There'll be bangs and question marks everywhere. So essentially, if we try to go that route, immediately people will be like, well, give me a mode that makes me do the safe thing. Break me, please. Essentially, punish me for the code I have now and make me do something else. Well, if we're going to break you anyway, then we kind of lost the benefit of adding these two new concepts. We might as well break you by taking the existing syntax and reinterpreting it, giving you a mode where that is reinterpreted as something else. And that's the path we're going to go down. Because now existing code already means something safe. It's either we have to decide, OK, do unannotated, when I just say string here, do I mean nullable but now safe nullable, or do I mean non-nullable? Either way, I kind of have to.
I'm guessing that if I declared a variable, I probably want to put something in it.
Yeah?
Yeah. So it's probably not null most of the time.
Yes.
Because I probably wanted something there.
Right. So you could reason either way. Like a lot of people say to us, well, obviously types today can have nulls in them, so they're nullable. So the new thing should be non-nullable, right? So it should be that link here doesn't need annotation, but this one up here needs an annotation saying it's not null. And then the new thing, that the way we break link here is that we start checking when you dereference things that are nullable, we start checking that you actually knew that they weren't null. Like we start enforcing the conditional checking.
Yeah, I'm trying to think through my code bases, and I'm going to add a lot of bangs.
Yeah.
Because in most of my designs, I would be trying to say that this shouldn't be null.
Yeah.
Because otherwise I've got if this isn't null, or Elvis operator everywhere, here, there, all over the place. So I'd probably try when I can that in my constructor I'm going to initialize something to non-null, and then I'm going to use it, and it's always safe. And then try and avoid those checks, and try to only put the checks where somebody might be trying to set it to null.
That makes sense to me. So so non-null is a good default, right? If I want null, that's an extra thing. It's like the option of T that we had before. That's the extra thing that you have to opt into. Oh, I want to be able to express null here, and I want to take the extra hurdle of then doing the checking around it. That should be the opt-in. I'm glad you said that, because that's what we actually did.
Oh, that's good. It's almost like I knew the script.
Yeah, it's like you've been here before. It's like you wrote the documentation for this.
Yeah.
OK, so this is what we actually ended up with. OK, so, but this is weird. Like, we now have a feature that is a breaking change. We've never had a breaking change in C# before. We have a feature that takes your existing reference types and makes them mean something else. A feature that starts punishing you if you put null into your reference types, which is the only place you could ever put them before. So that's a bit drastic. And of course, that has to be under a switch, some kind of an opt-in. mechanism. So I'm going to go and opt in now, which I can do in my project file for the whole project. So I'm going to say enable to this feature, nullable reference types, and save that, and go back to my program and see what happens. What happens? Ooh, I start getting warnings. So the feature is doing something. It's warning me about things. I didn't add any, well, actually, I did add an annotation. Let's take that away and just see, like, just in the vanilla code. Like, if you went and turned this on vanilla code that you hadn't done anything to, what would happen? Well, you'd start getting warnings here and there. And the warnings you'd get should be that we were trying to prevent you from putting nulls into the things into your reference types because they're now non-nullable. And sure enough, here I'm getting a warning. Why isn't it an error, by the way? Why are we just giving you warnings? Well,
I tried turning it on once, and I set warnings to errors, and I turned it off.
Yeah. Well, you might get a lot of them.
Yeah.
So that might be one reason. Another thing is that errors actually have semantic meaning in C#. We actually decided that this feature, in order to, because we're adding these nullable reference types to, billions of lines of source code out there and hoping for adoption of it, there has to be as little impact as possible. So this is a compile time only feature. Okay? It does not in any way, shape, or form change the semantics of the language at runtime.
So I think this is something that I think, if I understood exactly what you said, I think this makes me feel a lot better about turning it on my existing things. So if I turn it on, I don't change any of the source code anywhere. I'm going to get some warnings. If I've got warnings as errors, okay, I'm going to have to do something, maybe turn it off, maybe do something. Well, hopefully you've got a solution there. But if I compile it and I get an exe, its behavior will be exactly the same as it is before this feature came.
Yes.
So you're only breaking me at compile time.
Yes.
If I no matter what I do, my exe is going to be the same. So as long as it's been tested, I'm probably okay.
That's exactly the idea.
As I was before.
Yes.
Okay.
That's exactly the idea. So
I'm still skeptical, but I'm feeling better.
I'm glad. Okay, let's see. We still have half an hour left. Hopefully, I can get you all the way there. Or you'll walk out before you do your part of the talk.
Okay.
So warnings only, because errors actually in C# errors in weird ways actually have semantic impact. It has to do with overload resolution and lambdas and stuff. But actually, if you put new errors into the language, you're changing semantics. So it's just warnings. You can turn on warning one as errors, and that's not impacting the semantics of the language. So if you really want your errors, you can get them. But we're not making them errors. We're just making them warnings. Because your code still means the same, you should still be able to compile and run it, deal with the warnings later. So that's the reason for that. Okay. Now let's go and chase down these warnings. Let's see what's happening here. So sure enough, the thing that's getting a warning is a null. So that's good. It says, I cannot convert this null literal to the non-nullable reference. OK, so I'm calling the constructor down here. And sure enough, it says linked, which now means a non-null. So if I want to be able to pass nulls in there, which I do, I think I do.
Yeah, we need the list in someday.
We need them in there. Then I should annotate this. OK, so the warning is making me improve my signature here. OK, now I can't assign it into the property. Well, I can make that one nullable as well. Great. OK, great. Now we're back to consistency.
Oh, wait, there's a new one.
Oh, but now I got another warning. What is this one saying? It's saying, hey, it looks like you may be dereferencing a null reference, a possible null reference here. And we're back to getting what was the error before when we used the option type. We're back to the point in the code where it's telling us, you should probably check whether this thing is null before you're using it. So how can I check for null?
I would do question mark dot before next. Or is that going to be wrong?
What will happen if I do?
Oh, no, that's not going to help us at all, is it? No, you're right. That doesn't help.
Well, now I get a...
Yeah, no.
Then I'm passing a null to this.
Yeah,
and then I could make that one nullable.
Yeah, no, that doesn't help us.
But now...
No. These nulls do get in the way a lot.
Yeah. No. Now I get a warning here, right? OK, possible dereference. So either way, we can't get away from this. We have to do something conditional. It will not let us recurse forever,
right.
Which is, great. So we have to decide. We could certainly make it so it prints a link question mark. And maybe we should. Maybe we should keep the signature like this. But we can't get away with just, conditionally passing null here.
Yeah, I like the signature as a link. I think that's better.
Yeah, what we should... Oh, you want to do it on link? We can do it either way.
Yeah.
So Now here comes another thing. Like what you saw in the option version of it was that I used pattern matching, and there's sort of like a correct by construction thing, where if the thing was not null, I got the non-null value in a fresh variable, and I could just use that one, and there was no way I could do it wrong. And we can attempt the same thing here using pattern matching. So we can say if link is, if it is actually a link, then call it, if link.next, is actually a link. Because that checks, that only fires when it's not null.
Right.
Then call it next, and then do those things. Actually, so I want to do that on the next line here. Let me move that down. Then, print next. Now I'm doing exactly the same thing, pretty much the same thing as I did before when we had the other type-safe version of it. Then I can print that next. Okay? So I'm conditionally doing the recursive call.
Yeah.
But that's not how I used to check for null, right? That's new. Pattern matching is kind of newfangled, and it's correct by construction. That's great. But you have all this source code. You have all these millions of lines. That's not how you did it. You probably remember to check for null.
Not equal to null. And
you had tests, and so a lot of your code is actually null safe.
Right.
And it didn't look like this. So we can't just say, oh, yeah, okay, we're using the old null, but you have to have a new way of checking for null. That's no good either. So we have to be able to recognize your existing ways of checking for null. That's another way of sort of, because you want to use this feature to check that your existing code is null safe and point out where it isn't. It's no good if it warns every place you're not using pattern matching. I'm sorry. I mean, that's just not, there's like pattern matching in 0.3% of all the C# code out there today. I'm just making that up.
I'm trying. I'm writing about it.
Yeah?
I'm writing about it.
Yeah, but I mean, so that's not fair either. So what we want to do is we want to actually recognize your existing old-fashioned null-safe code. So let's say that I said if link.next, let's try this one. If link.next equals null, return. That's a different way of doing it. I might have done that in the past. Then if I get here, I will print link.next. And now you notice I'm not getting a warning. If I didn't do the check, I got a warning. But if I do the check, I don't get a warning.
That's magic.
That's magic. Or to use a different term, it's flow analysis. So we're actually going to lengths to track your variables through the flow of the code and see where do we think they can be null. So that's the way that we're trying to accommodate the fact that you didn't write code that was correct by construction in the past. In fact, you couldn't, but you were still null safe. Right? So we will track the value of variables and whether the compiler thinks it can be null at a given point. And it knows that if it gets down here, link.next can't be null, because if it was, then we would have returned. This is completely safe, right?
Yeah.
Can anybody see a problem with this? Yes? Another thread could have modified it in the meantime. That's correct.
Yeah.
Or, I'm not calling a whole lot of things here, but some call that I have could secretly have accessed the object through some other alias and changed it. Then you don't even need multiple threads. Just because it's null up here doesn't necessarily mean that it's null down here. And so, as sort of a courtesy to existing code, we allow this to go through anyway, which shows an important point that there's a trade-off between the amount of pain we want to inflict on you and the accuracy that we can do this with. If we wanted to be more accurate, we would only track local variables, and only if no lambda had captured them and somebody else could execute something that mutates them. So that would be the safer thing to do. But then more of there's lots of existing code like this, right? And more of your existing code would then generate warnings, even though you knew when you wrote it that it was safe enough. But okay, we are missing the opportunity to tell you about maybe a race condition.
I'm going to be evil.
Okay. You're going to be Machiavelli?
I'm going to be evil.
Okay. Tell me what you're doing.
I'm just going to show how you can be evil here.
Okay.
There. There's one next here.
Okay. Oh, so you're going to use an evil null check? You're not evil enough, I'm afraid.
Yeah. Wouldn't that be evil enough?
It's not evil enough. We're still catching up because it doesn't know that you are.
Oh,
it doesn't know that you're pretending to do a null check.
Oh, yeah.
Well, you could make link.next sometimes return null, sometimes not.
Yes, you could. So the implementation of next itself.
How's that?
What did you do?
Because I know I did an evil null check there. So I just added an exclamation point.
Oh, we haven't talked about exclamation points.
Okay, I won't do that then.
So there are definitely ways that you can trick it, right? And even if you're not Machiavelli, but you're just Murphy, there will be places where this will not catch your null reference exceptions. This is not going to guarantee that null reference exceptions go away. It's just going to take care of the vast majority of them. But we want to hit that, probably not 80-20, but more like a 90-10 trade-off, where we get almost all of them, but we really don't want to cause you too much pain on your existing code. And so that's essentially the design rationale here. We're not in a black and white situation. We're trying to find the right place in the gray zone between reasonable convenience on upgrading existing code versus reasonable safety around nulls. So that feels a little dirty, but the extremes, we've tried one extreme of it, which is not to check anything. It's extremely convenient. You never get new errors, new compile time errors in existing code. And we've seen sort of the functional other extreme of it, and it's unwieldy and practically impossible in an object-oriented language. So we have to put ourselves somewhere in the middle. And that somewhere is different because C# is an existing language with existing code than it might be in a new language, where you can take it a little further probably to the correct side, because you can make everybody use pattern matching always in a new language, for instance, or other correct by construction features. Now, you kind of broke us into a little extra feature that we have. There are these places where you know better, okay? Like here, let's say it wasn't evil null check, but it was just null check, okay? So I'm just going to rename it for now. I'm not actually going to make it not evil. But let's say I know that after this, I checked for null, but the compiler doesn't know. Well, there's several things that could happen here. Actually, several utility methods have special null semantics. There's string.is null or empty and stuff like that. And we're coming up with this little attribute language that we're going to let you attribute some methods as having special null behavior, and the compiler is going to recognize those. That gets into the gnarlies. But even then, there's going to be situations where you know better than the compiler. And that's what we have until recently called the damn it operator, which is like, I know what I'm doing, shut up. And we can't call it that for various reasons. So we're going to probably call it the suppression operator or something like that, which is a postfix bang. So it kind of looks like damn it, asserting, this is all right. Don't give me warnings on this particular conversion. And it makes the warning go away. But now it's like a cast. You sort of took responsibility that if an exception occurs here, you kind of ask for it. Right? If you weren't right, that you knew what you were doing, well, it takes you back into the old world temporarily. Yeah.
How bad do you feel when you use that in production code?
So
how nervous do I need to be?
John asks, how bad do I feel when I use it in production code? I would be very wary of it. Generally, if you need to use it in order to interact with another API, then something's probably wrong. If you have an implementation detail where, say, there's an invariant that when this Boolean is false, then that thing is never null. Right? We have lots of those cases in our little implementation types in the core libraries, for instance. Then that's this invariant. You put it in a comment. You say there is this invariant, and essentially every bang in your code should be accompanied by a comment saying why you think it's okay to have it there. That would be my guidance. Right? And make sure that it's very locally scoped.
There's a few other places where I've seen it as I've been starting to work through docs where we're going to talk about migrating code bases. If you think of your average DTO object, pulling data out of a database and stuffing fields in, most of those have public getters and setters because serialization is really hard on an immutable object. So those properties are going to be initialized to null. And then, but before you ever actually see it, because we're going to deserialize something into it, then they become non-null. Those properties the compiler is going to complain about because, hey, you can construct this by default. It's going to all be null. These are all bad. Mm-hmm. And then there's some idioms I'll show in the next hour to say, here's how I can say, I know this doesn't happen because of the semantics of the object. And like Mads says, though, if I'm just hitting bang, I'd probably feel really bad. But if it's like, okay, I know how this thing was designed. It was designed not to be null in some other way that flow analysis won't help. Then I can turn it on and I can say why I did turn it on.
Yeah. So don't be Tony Hoare at 3 a.m. and be like, oh, nobody's going to care. Yeah. So, but that's a good segue to talk about how does this feature work in connection with initialization. We talked about initialization. It can be hard to it can be hard to manage, but we try. So here's a class where it's a person class. It has first name, middle name, and last name, and it has a convenience constructor that only takes the first and last name and assigns those in. And I'm getting a warning on it by the feature here, which is saying that there's a non-nullable property that I'm not initializing. So essentially, the compiler tries to make you initialize all the non-null things in the constructor. And that's how you're going to discover many of the places that this type, that your types should actually put question marks in, that they should actually advertise nullability. So sure enough, if I can try to circumvent this in various ways. I can say, okay, it says it's uninitialized. Well, I'm going to initialize it. Let me show you. I've initialized it. There you go. And the warning goes away, but I get another one saying, hey, you can't assign null to that non-null thing. That didn't work. And of course, this is where, if it's 3 a.m., I would just do this and like, okay, walk away. But and sometimes, if you're in a situation where you really know that it's going to be initialized through other means, or it's okay for some reason, yeah, you can put the bang there, or you can put an initializer on it with null bang, and that's how you opt out, saying, okay, I know better. You know that you have this factory method that's actually calling the constructor and filling in the remaining fields, whatever it is. But what we really should do in this case is just be honest and say, okay, middle names, in this model here, probably in reality, all names can probably be null. Like it's not everyone who has a first name or a last name or a middle name. But for simplicity, let's just say the middle name here. Just be honest. It can sometimes be null. Now everything's happy here, but of course, if I go and use it, if I go and write the print method for persons, static void print. This is all print method sets. It's only tested on print methods. Person.
What else is there?
Right? And who, with debugging these days,
Points,
who even needs
persons,
yeah.
Print. That's pretty much all we write.
So now if I say console or write line, let's just say write line of, let's do an interpolated string, and we say, let's call this person is too long. Let's see, p dot first name. We can say p dot middle name here, but if I could p dot middle name, and so on, right? But and I'm allowed to do that. I can print null. But let's say that I want to abbreviate the middle name, so I'm going to do this here. Okay, I'm just going to print the first letter of the middle name. Now I actually get a warning saying, hey, you're dereferencing something that might be null, and so it's helping you here. Which so I really should do a conditional here and print it differently.
Or here I could use the question mark.
I could, so I could use the question.
No, or p dot middle name question mark 0. After middle name,
Uh,
right there.
I could, then I would get null if,
Right, but it's okay to print nulls. We just said that.
yeah,
Yeah?
yeah.
Yeah.
That's right, I could do that, yeah. Let's say, so, but it helps me realize the problem is there. And so actually, one thing that you shouldn't let this feature do to you, and I think many people have the, just because non-null is the default now, many people sort of have the,
There we go, we're back.
there we go. Many people sort of have the, okay, we should actually be avoiding nulls now. To be null safe, we should avoid null. And you can easily go too far on the null avoidance. Like avoid avoiding null is sort of what I would say. If null is warranted, better to use null than to try to substitute some other default value. So let's say that, okay, I wanted to deal with this problem by assigning the empty string to middle name. Okay? Now it's not null, so everything's fine. I circumvented the problem, but now, you know, this is still going to crash at runtime because it doesn't have a first element or 0th element because it's empty, right? So in fact, I should probably have a check in my constructor that you don't put nullable string or put empty strings in any of the name fields. So you just chased it out of the area that we just learned how to reason about at compile time and give you warnings about. It's better to use the actual null and the actual nullable type and then get the warnings when you're not doing it right. Don't shy away from using nulls. Use them whenever they make sense. So I think that was an important point to get.
Yeah.
There's a few more places. So we talked about there are holes in this. One of the big holes that I do feel bad about is arrays. Mm-hmm. So there's a lot of arrays in the world. Probably, like scientifically, around 50% of them are arrays of reference types. I'm just making up a number. Okay. So all over the world, there'll be people saying var array equals new string 10. Okay. Nowhere in the world is anyone yet saying new string question mark of 10. Because they can't. It's only in C#8. It's not out yet. John Skeet will have some code that does it, but that's only because he's using the preview. Okay? So this is what's going to be there all over the place. Millions and millions and millions of lines of creating arrays that will now be interpreted as arrays of a non-nullable reference type. And it's full of nulls. Right? There's 10 nulls in there. Should we give a warning on that? Yeah, we probably should for correctness sake, but we'd be like all that code, which is probably like the next thing it does is probably to initialize the array with proper and good non-null values, right? In all the cases where you don't mean for null to be in there. Like when you mean for null to be in there, of course, yes, you should go and put the question mark in. But when you don't mean for null to be in there, that's just what you were able to say, and then the next 3 lines will be initializing it in a for loop or whatever. What can you do about a warning that says you shouldn't create this array of non-null? I mean, 3 lines down, it's going to be fine. You knew what you were doing. How could you silence that warning? How could you possibly make it shut up?
Make structs.
What's that?
Use structs all the time.
Yeah. So then the struct has what inside? A null.
Yeah, that's probably.
So I mean, this is one of those difficult ones. So we've opted to not give you a warning on that. We've talked about there. So there are these places where we don't go and we don't favor correctness. We talked about having sort of a ludicrous mode where you tell the compiler not only should you turn on nullable reference types, but you should like go all the way, correct by construction. Don't let me build anything that has like these unwarned nulls inside. Like go all the way, as far as we can. And probably there'll be tiny little errors or holes that just constructors calling virtual methods, doing something in a derived class we don't know about. Like there'll be places where we can't go, that we can't figure out, that it's just not doable at compile time. But anything other than that. Or maybe we want on constructors calling virtual methods of any kind. Make the ludicrous mode that will not let any of this seep through. And maybe some people will want that, in particular for new code, or if they have security critical code. So we're talking about, and if we don't make the ludicrous mode, there'll be somebody like John or whoever will write the analyzer that does it, that adds the extra warnings. And so I think there will be that mode as well out there. And the fact that you have the ability to express the intent, to put the question marks or not, that means that we can now have these analyzers, and we can have different levels that can exist out there, different levels of rigor around how we then enforce it. So, okay?
Yeah. There's a few that you went pretty quick here, since this is your last demo part, right?
I think so.
Because that bit of empty string and such is one that I think we're going to get. I'm already seeing questions and discussions about this, because we already had the empty string forever, which was how you represent there isn't a string here. But it's almost like this extends to other reference types more importantly, in that right now the only way you represent there isn't anything here is null. So string is kind of special, because sometimes we may be using it just to print, so it might be right just to make it the empty string. But this whole redefining to have a different meaning for null, I think that's going to be an interesting way for people to really have to question what is the right way to fix code that uses that type, at least.
Yeah. I mean, the empty string isn't a very good solution here.
No.
Right? It's not just that we can index into it. Hey, if we actually if we output the last name here as well, and the full middle name, even if it's null and nothing comes out, you're going to have 2 spaces between the first name and the last name. It's just like it's just not good.
No.
You want to special case whether it's there or not, one way or another. But yeah, we're solving the null problem, but all of the length-related problems, null reference exceptions are probably by far, by orders of magnitude, the most common exception. But the next one down is probably the index out of range exception, right? Or similar, like you're indexing into a string or an array or something, and you got it wrong, right? And so there's that next level down of, is there some static analysis that could help you always stay within range? Well, that's a much harder problem still. That's hard. And it's not, I don't personally believe you could probably ever add that to an existing language. You need a language that has safer constructs to begin with than dynamically allocated arrays and so on. It'll probably be restrictive in very annoying ways.
No, but I like this. I think I'm starting to see some things where, as we start to modify some code in the next session, I'm starting to see the plan. My idea here is, if I'm looking at something, is not just to get rid of warnings any way I can. It's to look at those warnings and ask myself, what's that expressing about what my design was?
Yes.
And how my design isn't really expressed in my code. And then modify my code to go, okay, now the compiler agrees with me about what my design was. And then if I fix it that way, I probably have less to do because I had a design intent. And if I fix it by getting it that way, then the compiler is helping me make sure that the code I wrote expresses the design intent I had.
Right.
I like this.
Good.
Good work.
Ooh, just in time. We have a minute left, so I won you over. Now I just have to be careful in the last minute not to say something that will turn you around again. So I think we pretty much covered everything here in terms of the language design. There are little details that may become bigger details when we get into Bill's talk. I opted the whole project in to the new harder semantics. I said, please break all my code in this project by changing some setting on at the project level. And you might wonder, as you migrate code, is that the right granularity to opt into this new world? And that's something that there are ways of doing it in a more granular fashion that I didn't show, and that's something that I think we will see in Bill's part in the next version. So there we will look at both, how should I think about it when I write new code, and how should I, and by example, Bill's going to upgrade some code on stage and take us through the steps of becoming null safe with your existing code. So that's pretty much it. Go have a break, and if you want to hear the second part, Act 2, where Bill's the hero, then please come back in 20 minutes and see you then. Thank you so far.